Welcome to The Explainer. Today, we're jumping into a really fascinating puzzle right at the heart of conversational AI. We all just kind of assume that making a voice assistant smarter is the key to making it better. But what if the real secret isn't about intelligence at all, but about pure, raw speed? Okay, so let's get right into it with just one single, pretty startling number that kind of changes everything we think we know about building a great voice agent. 694 milliseconds. That's it. It's a little over half a second. A developer over on Kita recently published a case study, and they clocked this as the total time it took for their voice agent to start talking back after they finished. I mean, that is incredibly close to how fast a real human conversation flows. So you have to ask, right? How in the world did they pull this off? What kind of groundbreaking, super powerful new AI model are we talking about to get that kind of response? Well, that's the gut reaction, isn't it? A smarter, more intelligent large language model, an LLM, must be what creates a more natural conversation. But the data from this case, and frankly the entire industry, is pointing somewhere completely different. So let's peel back the curtain and break down what's actually happening inside those 694 milliseconds. Because it's not just one thing happening, it's a whole chain of events. They usually picture it as a simple three-step relay race. You talk, the AI writes it down as text, the big brain LLM thinks of an answer, and then a text-to-speech engine speaks it out loud. And it seems like the LLM is doing all the heavy lifting, but that's not the whole story, not even close. In fact, just look at this breakdown. The LLM. It only took 209 milliseconds to come up with the very first word. Then, the system just sat there for another 193 milliseconds, basically waiting to collect enough text to make a coherent phrase. And then, get this, the text-to-speech engine took a whopping 291 milliseconds just to fire up and make the first sound. The thinking part is actually just a fraction of the delay. And this brings up a really counterintuitive point. That same case study found that running the text-to-speech part locally on a regular CPU was a huge bottleneck. We're talking over 2.5 seconds for longer sentences. But a cloud-based streaming service, it started making noise consistently in under 300 milliseconds. So the biggest slowdown wasn't the AI brain, it was the digital voice box. And this single insight is causing a massive shift across the whole industry. It's not just about who has the smartest model anymore. Now it's a race for who has the fastest pipeline. You've got industry leaders like Twilio coming out and totally redefining what success even looks like. They're not talking about model benchmarks. They're talking about this, the mouth-to-ear turn gap. And what this really means is that we're finally measuring the entire experience from your perspective, the user's perspective. It doesn't matter how fast any one part is on its own. The only thing that truly matters is that awkward silence you experience between the moment you stop talking and the moment you hear that first syllable back. This benchmark from Twilio kind of shows a typical latency budget. You can see to get a response in just over a second, they budget 350 milliseconds for speech to text, 375 for the LLM to spit out its first word, and just 100 for the text to speech to get going. Every single millisecond is accounted for, which proves that performance isn't an accident, it's a feature you have to design from the ground up. So, with this new obsession with speed, developers are now at a fork in the road. They're facing a choice between two really different ways to build these voice agents. On one side, you have that traditional cascaded pipeline, that three-step process we talked about. It's modular, it's flexible, but on the other side, you've got these newer speech-to-speech models that take your audio in and spit audio right back out. They promise lower latency, a more natural emotional tone, but they also give you way less control. And here's the thing. While those slick integrated speech-to-speech models are probably the future, for a lot of businesses right now, that practical, controllable, and much easier to debug cascaded pipeline is still the more realistic choice for actually getting a product out the door that works reliably. But look, getting the tech architecture right is really only half the battle. The real art of a good conversation, whether you are a human or an AI, is all about mastering the rhythm. We pour so much energy into the intelligence of an AI's response, right? How clever is the thing it says? But there's a much more basic, fundamental element at play in any conversation. Because honestly, the most critical and most overlooked part of a conversation feeling natural is simply knowing exactly when your turn to speak has actually begun. In the biz, this is called turn detection. It's the AI's ability to figure out the difference between a thoughtful pause and the actual end of a sentence. If you get this wrong, the AI either steamrolls you by interrupting all the time, or it feels painfully slow. And it doesn't matter how brilliant its answers are. So let's bring this all home. When you're building a voice AI, optimizing for that conversational tempo, not just raw intelligence, is the absolute key to making something that people will actually want to talk to. That choice to focus on the whole pipeline versus just plugging in a smart LLM leads to wildly different experiences for the user. In the best case scenario, you've got a super optimized pipeline. You get a response back in under 1.1 seconds. The user doesn't even think, wow, this AI is smart. They just feel like they're having a real fluid conversation. It just works. But in the worst case, a team just grabs the latest, most powerful model and completely ignores the audio pipeline. The response takes over 2 seconds. And that long, awkward silence, it makes the AI feel incompetent, clumsy, and it completely shatters the user's trust. In voice AI, slowness isn't just a bug, it's a fundamental failure of the entire product. So, what's the big takeaway here? In the world of voice AI, true intelligence isn't measured by how complex the answer is. It's measured in milliseconds. It's not about what the agent says, but how quickly and perfectly it knows when to start saying it. That right there is where the real magic happens.